Hello everyone. This lecture is before the contents of the principles of electric circuits. It's about the math basics for circuits. The reason we prepared this lecture is because some students learn this MOOC in the middle school, and some learn the course in their first year of the university. So we prepare the math basics for circuits for you. Firstly, we need to review the concept of arithmetic and algebra, and then the concept of the calculus. Arithmetic means the calculation of the numbers. For example, 1 plus 1 equals 2 is a addition calculation of two numbers 1 and the result is 2. Besides addition, there are also subtraction, multiplication, division, exponent, logarithm, and so on. These calculations deal with specific numbers, which you've been familiar with since your primary school. One breakthrough learning in your middle school is from arithmetic to algebra. Algebra means using variables and functions to represent numbers. In other words, corresponding to 1 plus 1 equals 2 above, we use a plus b to represent addition and a minus b to represent subtraction, in which a and b are both variables. Similarly, we use y equals a times x to represent a function. This is a function of x, and a is a given value. These are the variables and the functions. All of them are algebra. With the concept of the variables and the functions, you will learn how to describe the accumulated effect and the rate of change of the variables in university. They are the essence of calculus. Next, let's introduce the accumulated effect and the rate of change respectively. Firstly, let's focus on the accumulated effect. We suppose all the functions have the variable t. With the function of t, the accumulated effect means the area enclosed by the coordinate system in which the horizontal axis is t. To solve the area, the mathematical calculation is called integral. Let's take an example. You've learned in the middle school that Newton's third law is F equals m times a, which means force equals mass times acceleration. In the middle school, the acceleration is always a constant. In this condition, the speed of the object is v equals a times t. We suppose the speed is 0 at t equals 0. Besides, the displacement s equals 1 over 2 times a times t squared. We suppose the displacement is 0 at t equals 0 too. Let's see, when a is a constant, how do the speed and the displacement represent the accumulated effect? This waveform represents when a is constant. A doesn't change with time. If we want to know the accumulated effect at t equals capital T, we can solve the dashed area from t equals 0. It's easy to solve it. It's a rectangle. The length is capital T and the width is a. So its area is a times capital T. You can find that it's the same as v equals at, which is illustrated above. Similarly, let's see the accumulated effect of v equals at. Let's solve the accumulated effect at t equals capital T. That is the area of this part. It's easy to find this area. This is a triangle. The length is capital T and at respectively. So the dashed area is 1 over 2 times a times t squared. You can find that it's the same as the displacement formula in the middle school. What can we get from the two graphs? The accumulated effect of the acceleration a is the speed v, and the accumulated effect of the speed v is the displacement s. The mathematical expression can be the integral of the acceleration is the speed, and the integral of the speed is the displacement. We've discussed a simple condition in which the acceleration is a constant. In real conditions, the acceleration can be changeable, such as a variable. Similarly, we can still solve the dashed area for t equals capital T. The dashed area is the speed of the object at t equals capital T. Similarly, we suppose the speed of the object is changing with time, but not linearly. We can still find the dashed area at t equals capital T. The dashed area is the displacement of the object at t equals capital T. So you must remember the integral is to find the area, that is the accumulated effect of a variable. How to solve the integral of a given function, we will discuss it later.